Hello, I'm Rose Galaxy 425. I apologize for not posting in a while. I just don't know what to post about. I want to try something new, man. I want to do sorry about the background noise, if there's any on the video. I don't know how sensitive the noise is. Despite that, I'm gonna continue with this. I try to do a solar system project where I basically do presentations on the planets and the sun, because I try to learn more about them. So basically, it's out of curiosity. Again, sorry if there's any background noise. The information and the photos are all from the internet. If you want to just go through the videos, see the slides, great. If you want to actually watch and listen, then that's awesome too. The first thing we're going to cover is the layers of the sun. As you can see, I got 3 photos here. The middle one's more simplified. The first one kind of is more detailed, and the last one there is kind of a mixable, I guess. It's simple yet kind of detailed. First, we're going to start with the internal layers. So as you can see, there's core radiative zone, interface layer, and convection zone. The interface layer is not all diagrams of the sun, but some diagrams do show it. The core, let's start with the core. The core is the hottest part of the sun, and is the place where nuclear fusion takes place. This consumes hydrogen to form helium. The core can reach temperatures up to 15 million degrees Celsius or 27 million degrees Fahrenheit. The core contains about half the sun's mass. Radiative zone. This is a zone in the star where energy travels outwards as radiation. The energy generated from the core is carried by photons and bounces from particle to particle in the radiative zone. Interface layer. The fluid motions in the interface layer slowly disappear from the top of this layer to the bottom where it matches the call of the radiative zone. Convection zone. The temperature is about 2 million degrees Celsius at the base of the convection zone. The convection zone makes it hard for radiation to get through and it traps heat. This causes convection, which I forgot the definition of. I'm sorry. Now we're doing the outer layers of the sun. These outer layers are basically considered the sun's atmosphere. The first, the innermost layer is the photosphere. This is the visible surface of the sun. The photosphere is, I already said that was the innermost layer. Chromosphere, an irregular layer of the sun where the temperature rises from 6,000 degrees Celsius to about 20,000 degrees Celsius. This layer gives off a reddish color due to the light the hydrogen gives off at this temperature, and a violet from the light given off by ionized calcium. Interface layer, a very irregular layer of the sun that separates the cooler chromosphere into the hotter corona. Corona, the outermost layer of the sun's atmosphere. And then here's a link that might help a little bit if you're looking for more information. Solar storms. The first solar storm we're going to cover is the solar flare. Solar flares are powerful bursts of energy, light, and high-speed particles that are released from the sun. Like earthquakes, solar flares are put into classes by amounts of energy. The classes represent a tenfold increase in energy output. Each class is then divided for numbers 1 through 9. And then as you can see, I kind of show that each one is 10 times stronger than the other. A-class through C-class flares don't affect technology, while M-class flares may propose minor inconveniences such as brief blackouts at the poles or minor radiation storms. X-class flares don't have an upper limit, and they are associated with coronal mass ejections that can cause radiation storms. Can interfere with their hard technology. Coronal mass ejections. The corona is structured with strong magnetic fields, so areas where the solar atmosphere is confined can suddenly release balls of gas magnetic fields. Basically a bunch of solar material. Coronal mass ejections can travel at millions of miles per hour. These often fall after a solar flare. Radiation stores. Radiation stores occur after major eruptions from the sun when photons get launched at super high speeds. Radiation stores are also divided into classes based on intensity. And the photo down here kind of shows or represents it, so you kind of understand what's going on in the next slide. Radiation storm classes. S1 radiation storms have minor impacts on technology. The class starts at the proton flux unit threshold of 10, or 10 to the first. S2 radiation storms propose a moderate impact to technology. This class starts at the proton flux unit threshold of 100, or 10 squared. S3 radiation storm classes have a strong impact on technology, can cause radiation to astronauts or high-altitude aircraft passengers. This class starts at the proton flux unit threshold of 1,000 or 10 to the cubed. 10 cubed. S4 radiation storms have a severe impact on technology and are a bigger radiation hazard for astronauts and high-altitude aircraft passengers. This class starts at the proton flux unit threshold of 10,000 or 10 to the fourth. S5 radiation storms have extreme effects on technology and satellites. This class proposes unavoidable high radiation risk to astronauts and high-altitude aircraft passengers. This class starts at the proton flux unit threshold of 100,000 or 10 to the fifth. Here are 3 links you can type into Google that might help if you want to know more information on solar storms. Mythology. Helios is a Greek god of the sun. In Greek mythology, he personifies the sun. I say personify because there's another sun god alongside Helios, which will be explained. It is believed that Helios drives a chariot across the sky from east to west every day. Helios is a titan that is personified as the sun god in Greek mythology. Apollo is the sun god of both Greek and Roman mythology. He resembles the light and radiance part of the sun. He is also associated with both music and archery. Being the sun god, he is energetic. Apollo is also associated as the son of prophecy and healing, but many of the gods in mythology have more than one role, so it's confusing. Soul. Like Helios, Soul is the literal embodiment or personification of the sun. There are 2 different versions of Sol that are believed to have coexisted. One is Sol Indigenous and one is Sol Invictus. There is not much more on Sol, but Roman and Greek mythology are closely tied, so I guess his soul is similar, if not the same, as Helios. Physical description more of the sun. The sun's radius is about 432,609 miles, or 696,000 kilometers. The sun's diameter is about 864,938 miles, or 1.392 million kilometers. The sun is an average-sized star. The sun has no solid surface. Different layers or parts of the sun rotate at different speeds. The sun goes through periods of no activity and high activity. the sun's gravity is 274 meters per second squared. The sun's mass is 1.989 times 10 to the 30th kilograms. Orbits the center of the Milky Way. The sun's orbit is affected by Jupiter. And now, this is the part where I have to stress. I looked this up on the internet, so different websites have different stuff on the sun. So even NASA might have slightly inaccurate measurements, or they simplified it. I used the simplified version. So, just be cautious of the sources you use. I tried sticking with NASA, but as we all know, when it comes to space and measurements, you're not going to get totally right on measurement of whatever you're looking for. So I looked around, and different sources have different things, so just a warning there. How the sun contributes to the Earth's ability to have life. The sun's heat is enough for life on Earth to be possible, but the sun contributes more than just that. Without the light of the sun, plants wouldn't be able to do photosynthesis. The sun also affects the weather since it is needed to make water evaporate. Magnetic field and activity cycle. The sun regenerates magnetic fields that extend out into space to form the interplanetary magnetic field. The magnetic field is carried through the solar system by solar wind. The vast mobile space that is affected by the sun's magnetic field is called the heliosphere. About every 11 years, the magnetic poles of the sun change their polarity. This causes a period of calm and a period of a lot of activity for the sun. And from the source I use, it was violent activity. So, there was huge amounts of activity that happened the high activity period of the sun. So, which means, there's a lot of storms going on. In the calm period, there's not going to be out of space. Low amounts of solar storms. Type of star in the future of the sun. The sun is a yellow dwarf, but I looked it up and how NASA described it. I guess that this is supposed to be more of the specific type of star. Is the sun is a G-type main sequence star, or G2V. Stars on the main sequence are at the longest stage of their life and are the most stable. These stars typically last 10 billion years. The sun has been around for 4.6 billion years, so it has a long time before it runs out of hydrogen to turn into helium. Once it does run out of hydrogen, it'll fuse helium and the sun will turn into a red giant. The sun will engulf Mercury, Venus, and most likely Earth, but scientists aren't certain. Yes, I know I made a mistake there. The sun will be a red giant for a while, but it will then shed its outer layers as planetary nebula and become a white dwarf. White dwarfs are about the size of Earth. It is predicted that the planets will remain in orbit, but the orbits might become unstable. The sun will then become a black dwarf, but planets will remain in orbit. Because the sun will still have gravity, it will just lose its light. It'll be completely dark. So, gravity's still there, but not the light. Here are some links for more information that you can type into Google. And congrats, you made it to the end of the presentation. as you can see, I was kind of messing around and just created this slide for fun. If you are a subscriber and you have made it to the end of the video, I just want to say, I know I usually do gacha content, but I just tried to do something new. Because I just can't get any ideas for gacha. It's not that I won't post anything gacha related. It'll just be like very long distances, which I have been doing in the first place because I keep running out of ideas. For those who are new and are watching this video, I know I should have said this at the beginning, but welcome. And to all of you, I hope you enjoyed this presentation. And I hope you look forward to seeing the rest of this project fold out. There'll be some boring, some fun presentations, so you'll just have to see. I know I'm gonna keep ya, so have a good day. And again, I hope you enjoyed. Bye.